Good morning, students. I am Mohammad Ashraf Wani, your host teacher, and today we will be discussing about the very first chapter of your science book, Chemical Reactions and Equations. Well, first of all, we will try to understand the meaning of this word reaction. Well, when we talk about this word reaction, reaction in simple terms means change. And change is of two types. Changes are of two types: physical change and chemical change. Well, we experience and we see there are so many changes which are taking place within us and in our day-to-day lives. And all these changes are categorized into these two basic parts, that is physical change as well as chemical change. Now, talking about physical change are those changes in which simply the state of appearance, the state or the appearance of a substance changes, in which the physical dimensions of a substance change. I will give a simple example about melting of ice. All of us know water in the form of ice exists in solid state. Now, when we see the chemical composition of ice, it is H2O. And when the same ice is heated, it melts to form H2O, that's water. Now, when we see the chemical constitution of ice and chemical constitution of water, it is same, H2O. So in this change, only the state, that is ice exists in solid state and water exists in liquid state. So only the state of appearance of the substance changes from solid to liquid. But there is nothing new is formed. We cannot say that something different has been formed from this ice, because chemically ice and water, they are same. Now, talking about chemical change. Chemical changes are the changes in which new substances with new properties are formed. Let's take an example of a reaction in which hydrogen reacts with oxygen, forming water. Now, hydrogen is a highly combustible gas, readily catches fire, and oxygen is something which supports combustion. Now, when these two combine together, forming water, now if we see the properties of water, it is not combustible. It does not support combustion. So in both ways, it's totally different from the reactants from which it is formed. Well, the substances which react and result in the formation of a new substance, these substances which are reacting together are called as reactants. And when reactants react, whatever new they form, that's called product. So reactants react together to form products. Now we have understood what chemical change is and what chemical reaction means. Now, when this chemical change is represented in the form of symbols and formulas of various reactants and products which are involved in a chemical change, it is referred as chemical equation. So chemical equation is a symbolic representation of the chemical change in terms of symbols and formulas of the various reactants and products which are involved in a reaction. Now, after understanding about what chemical reaction and equations mean, we'll be discussing about the characteristics of chemical reactions. Well, if there are so many changes which are taking place in our day-to-day life, and as we already discussed, few of these changes may be physical and few of these changes may be chemical. But how we can recognize whether the change which is taking place within us or outside world is a chemical change? Well, these characteristics will help us in understanding whether the change which is taking place, whether the change which you are observing is a physical or a chemical change. And the first characteristic of chemical change that we will be discussing is change in state. Well, let me take an example again of a reaction in which hydrogen combines with oxygen to form water. Now, when we see hydrogen combining with oxygen to form water, hydrogen and oxygen both are in gaseous phase. When these gaseous elements they combine together, they result in the formation of water. Now, this water exists in liquid state. So, what we observe is change in state of gaseous reactants. They change into liquid, which is the liquid product. So, what we observe is change in state. So, whenever we observe change in state taking place from reactant to products, we may say chemical reaction may have taken place. Well, why are we using the word may? Because we are here generating a possibility, because there are many physical reactions, as I told you earlier about the melting of ice. That can be also, that's a physical change. So we cannot regard, in that change also, there is a change in the state of substance. And here also we see hydrogen and oxygen, they are in gaseous phase and they change to what? Liquid. So here is also a change in state. So we can generate a possibility that yes, maybe chemical reaction may have taken place, because we have to support a chemical change with multiple characteristics. So the first characteristic which we had studied here, which we had learned here, is change in state. Now we will be discussing about the very second characteristic of chemical change, which is change in color. Well, how many of you had witnessed whitewashing in your homes? Today we will be discussing something related to same. All of you may be aware of the substance which is used for whitewashing, that is calcium oxide. Now this calcium oxide, which is commonly called as quicklime, when this calcium oxide reacts with water, it results in the formation of calcium hydroxide. Now, the reaction between this calcium oxide and water resulting in the formation of calcium hydroxide, commonly called as slaked lime. Now, this aqueous solution of slaked lime is colorless. If we take it, it is totally colorless. And in a very local language, common language, we use the word, it's called lime water. Now, how many times you might have studied this in your lower classes, that when we pass carbon dioxide gas through lime water, it turns lime water milky. Well, we are going to do something same here. Let's take this calcium hydroxide and we are passing carbon dioxide gas through this calcium hydroxide. Now, when this carbon dioxide gas is passed through this slaked lime, it results in a reaction resulting in the formation of calcium carbonate and water. Now, this calcium carbonate which is formed here is a white colored precipitate. The insoluble product which is formed, it appears in the form of precipitate and is white in color. So what we observe here is calcium hydroxide, which was totally colorless. Carbon dioxide gas is passed through this calcium hydroxide and the reaction takes place and results in the formation of calcium carbonate, which is white in color. So what we observe is change in color taking place in this state. And whenever we observe this change in color taking place during any change, we can say chemical reaction may have taken place. This was our second characteristic. The first was change in state. The second one is change in color. Now, third one is change in temperature. Well, I will take the very same reaction in which calcium oxide is treated with water, reacts with water, forming calcium hydroxide. Now, when you are reacting this mixture in a certain vessel, and if you are doing it with your hands, you will see the reaction mixture gets heated up. Well, when I say it gets heated up, it means some sort of heat energy is released during this reaction. Well, we have to understand this fact that no reaction will take place without the involvement of energy. And mostly the energy which gets involved is heat energy. There are reactions which are taking place which involve light, current, but here we talk about those reactions which are taking place with the involvement of heat. Now, there are certain reactions in which heat is given out and are referred as exothermic reactions. This reaction which we discussed just now about reaction between calcium oxide and water forming calcium hydroxide is an example of exothermic reaction. Even when we burn fossil fuels, we see on burning they give out heat. So all these reactions, combustion reactions, are examples of exothermic reactions. Now, there are certain reactions in which heat is not given out but is absorbed during the reactions, and those reactions are called as endothermic reactions. After this third characteristic of chemical reaction, which was change in temperature, we will now discuss the fourth characteristic of a chemical reaction, which is evolution of gas. Now, there are certain reactions in which we see certain gases are evolved when this reaction takes place. Whenever we observe any change taking place in which we see there is evolution of gas, we may say that chemical reaction may have taken place. Let's take an example of a reaction in which zinc reacts with an acid, HCl or H2SO4. Let's take an example of a very common acid, which is the king of the chemicals, sulfuric acid. We can see that this zinc combines with sulfuric acid, resulting in the formation of zinc sulfate, aqueous solution, and the gas released is hydrogen. Well, here it's a displacement reaction which is taking place in which zinc metal displaces hydrogen of the acid and hydrogen gas is released. So what we observe is the release of hydrogen gas in the reaction, the release of gas in the reaction. So any reaction, any change in which certain gas is released, there is an evolution of a gas taking place, we can say chemical reaction may have taken place. Now, this was about the evolution of a gas. After evolution of a gas, we will move to the fifth point, the fifth characteristic of a chemical reaction, that is formation of precipitate. Now, when we see formation of precipitate, we have to understand first what precipitation means here with reference to chemistry. Well, during chemical reactions, there are many insoluble substances which are formed. There are many insoluble substances which are formed in aqueous reactions, and those insoluble substances, they appear out of the solution, and when they appear out, that is what is called as precipitate. I will take an example of the reaction which we discussed just a few moments ago. I talked about the reaction in which you passed carbon dioxide gas through slaked lime, that's calcium hydroxide. When carbon dioxide gas is passed through slaked lime, it results in the formation of calcium carbonate, white precipitate of calcium carbonate. Now here you have to understand, this calcium carbonate formed is a salt, and this calcium carbonate is insoluble and it is not soluble in water. So when it is not soluble in water, it has to come out of the solution, and it comes out, appears out in the form of white PPT, white precipitate, and we can see the water as well. So these reactions in which we see that there are these insoluble products formed, that is precipitate formed, we can say these chains may be referred as, we can say they may be chemical reactions. So in totality, we had studied all the 5 characteristics of chemical reactions. I would try to recall them. The very first that we discussed was change in state, Second, change in color. Third one was change in temperature. Fourth one was evolution of gas. And the fifth one was formation of precipitate. And all these chemical changes, they are characterized by not just one single characteristic, but they may be having two or more characteristics, and where we can be very much sure that yes, if any change is having these 2-3 characteristics associated with them, we can say yes, definitely this is the chemical change, this is the chemical reaction taking place. Now, after understanding the concept of chemical reactions and the various characteristics of chemical reactions, we will now understand the concept of chemical equation. Well, when we talk about what chemical equation means, chemical equation is the shorthand symbolic representation of a chemical change in terms of various symbols and formulas of the various reactants taking place in a chemical change. For example, if I have to mention a very simple reaction of, say, burning of magnesium ribbon, I can say a few words about it, that we can take a piece of magnesium ribbon and we introduce it to the Bunsen burner flame, and we will burn it, and it will burn with a white dazzling flame. Well, in book also we have a proper activity which relates regarding this burning of magnesium ribbon. Now we can simply write it like magnesium burns in air to form magnesium oxide. Now when it is written in the form of words, this format of writing a chemical change is called word equation. Now if the same word equation is now written with the help of the symbols and the formulas of the various reactants and the products which are involved in the reaction, it is called chemical equation. Like Mg plus O2 gives MgO. Magnesium, it burns in oxygen to form magnesium oxide. And when we see how does it burn, this magnesium ribbon burns with a white dazzling flame. Well, there's one common question, which very important question, which comes in your exams as well. Why is it important? Why is it necessary? Why is it recommended to rub the magnesium ribbon before burning? Well, we see magnesium is a metal, and when exposed to air, it gets covered by the layer of magnesium oxide or magnesium carbonate. That is, this layer of magnesium oxide will prevent burning of magnesium ribbon easily. So what happens? We need to rub this magnesium ribbon with a sandpaper so that we can remove this oxide layer and magnesium ribbon burns easily. Well, this was about chemical equation. Well, I will repeat it once again. Chemical equations is the shorthand representation of a chemical change in terms of various symbols and formulas of various reactants and products which are involved in a chemical reaction. Well, when we simply write a chemical reaction, in a chemical reaction which involves atoms of reactants and products on both the sides of the reaction, these atoms on the reactant hand side may or may not be equal to the atoms on the product hand side. Well, here what we had studied in our previous class 9, about the law of conservation of mass, which simply states that matter can be neither created nor destroyed, or it can be also stated like this, that during any physical or chemical change, the mass of the reactants always remains equal to the mass of the products. Well, in order to obey this law of conservation of mass, we need to see the number of atoms on the reactant hand side of a chemical equation should be always equal to the number of atoms of the equation on the product hand side. So what we need to do is we need to balance the chemical equation on both the sides. And this balancing of chemical reaction is done in order to obey the law of conservation of mass. Well, I will give a simple example here of a reaction. Carbon combining with oxygen resulting in the formation of carbon dioxide. In this reaction, we simply see carbon plus oxygen O2 gives CO2. Now, if we see the number of the atoms of carbon on the reactant hand side is 1 carbon, and same is on the product side, just 1 carbon. And we have 2 oxygens on the reactant hand side and the same 2 oxygens on the product side. So we can clearly see here in this reaction, the number of atoms of carbon and oxygen on the reactant hand side is equal to the number of atoms on the product side of the equation. So this equation is a balanced chemical equation. Now, if we take an example of one more reaction of combination of hydrogen and oxygen to form water. Now, in this reaction, we clearly see that there are 2 atoms of hydrogen and combining with 2 atoms of oxygen, resulting in formation of H2O. So on the product hand side, we see that there is 1 oxygen which is missing. Now, normally what we do is, there are certain children who make mistake of writing 2 in the subscript on the H2O hand side, which is wrong. Because once you alter or write something as a subscript in a formula, it will change the chemical formula of the substance. So writing anything as a subscript in a formula is not allowed. So what you need to do is simply introduce the numeric stoichiometric coefficient in front of the molecule. Likewise, you have H2 plus O2 gives H2O. Now you need to understand, on reactant hand side you have 2 hydrogens, on product hand side you have 2 hydrogens. You have 2 oxygens, but on product hand side you have only 1 oxygen. So what you do is you write 2 in the front of H2O. Now this writing 2 in the front of H2O makes it 2 molecules of water. It means it is having 2 times hydrogen H2, that makes it 4 atoms of hydrogen and 2 atoms of oxygen. So we can understand it from here that this 2 which is written in the front of H2O is for both hydrogen as well as oxygen. But while mentioning this 2 in front of H2O makes here 4 hydrogen atoms. But on the reactant hand side, you have just only 2 hydrogen atoms. So in order to equate hydrogens, now what you do, you introduce 2 in front of hydrogen as well. So once you write 2 in front of hydrogen, it makes it 2 times H2, which is 4 atoms. So 4 atoms of hydrogen on reactant hand side, 4 atoms of hydrogen on product hand side. Similarly, we have 2 oxygen atoms on reactant hand side and 2 atoms of oxygen on reactant side. Hence, you can see the number of atoms of each and every element on the reactant hand side is equal to the number of atoms on the product hand side. So this reaction is now a balanced chemical reaction. And this balancing of a chemical reaction is done in order to obey the law of conservation of mass. I will repeat, it is done in order to obey the law of conservation of mass, which states that during any physical or chemical reaction, the mass of reactants always remains equal to the mass of products. So dear students, it was all for the day. We will meet again in our next video lecture. We will discuss about the types of chemical reactions. Till then, enjoy your time and goodbye.